Hello, this is Lab 1 charge tapes. So to introduce this lab a little bit, the main purpose was to prepare charged pieces of tape and observe their interactions and then determine approximately how much excess charge was on one of these pieces of tape, both experimentally and with modeled calculations. So the models we used were glow script code for our tape as a point charge and then for our tape as a line of charges. And the fundamental principles at hand were electric force, the force of gravity, and Newton's second law. And our main result was that we succeeded in determining an approximate charge that fell within reasonable values. So our main physics concepts to take note of are the force of gravitation and electric force. The force of gravitation is always in the negative y-hat direction, and it's just comprised of the mass of the object and the gravitational constant, whereas the electric force takes into account the charges of both objects interacting as well as the distance and directionality between the two of them. So in the situation I'll describe for our experiment, our top tape has both the gravitational force and force of electricity, which should cancel out to be zero, which allows it to hover. So our actual experiment was to make a piece of tape float using another similarly charged tape underneath it, which canceled out with the earth and the force of gravity. So our system is the charged tape on the top. Some initial conditions for our system was the mass was 2e negative 4 kilograms, the tape length was 0.2 meters long, and the distance between the two tapes where the top one floated was 0.026 meters. And some assumptions we had to make for this experiment was we had to assume the tape was lined up perfectly underneath, we had to assume the charges on both pieces of tape were the same, and then we also had to assume that there were no other electrical interactions with nearby objects. And there could have easily been some error in handling these charges, which would have removed some of the magnitude of the charge. And we also found this tape to be negatively charged, as I negatively charged a pin with some wool, and it was repelled by the tape. So for our experiment, we can calculate the charge on one piece of tape by using our equilibrium condition on our top piece of tape, where the force of gravity and the electric force will cancel out to be zero. So once we find our gravitational force to be negative 1.9 E negative 3 newtons in the y direction, that means our electric force has to be equal and opposite to this. And then we can rearrange our electric force equation to give us the charge on one piece of tape by plugging in all the other important information like the distance between the tape when the float happens. And this gives us a charge on each tape of approximately negative 1.21 e to the negative 8 coulombs. For my first coded model, we assumed that the charge was the same on both tapes, but we modeled the tapes both as point charges, so just 1 point for the top tape and 1 point for the bottom tape. And so this code is essentially the same calculations as the experimental ones. So I did all the same algebra to get the Q for the particles. And then we used our function to find electric fields to ensure that the electric field and gravitational field did indeed cancel out as expected. And so the charge of each tape in this model was negative 1.21 E negative 8 coulombs, same as before. In the second coded model, however, even though we still did the charge on both tapes as the same, our tapes were actually modeled as a line of charges this time instead of just one. So as you see on the left, that function basically is the one that breaks up our tape into all the different charges. And then the function on the right has us calculate the electric field at each different mini charge in the line and then add them all up to get our total electric field and then the force from the electric field. And so for this model, we actually found the charge of each tape to be negative 2.64 E negative 8 coulombs, and we'll get into the why in a minute. So for some additional questions, what would happen if electrons were positive and protons were negative instead? So although this seems like our electric fields would all be flipping and it might mess stuff up, there would actually be no change in interactions. Since the stuff that was similarly charged would stay similarly charged, they would still repel one another, and the things that were oppositely charged would still be oppositely charged, meaning they would still attract one another. And then why do the charge values in the point charge and line of charges model differ? So the reason this happens is our point charge model can utilize their charges repelling one another just completely in the vertical direction since they're right above each other. Whereas for our line of charges, there are actually interactions going left and right too, such as a charge at the end being pulled towards the middle as well, since it's on the end and there's more charges on the side, on the bottom. And so since there's some of our charge is wasted in the left and right direction, we actually have to have a higher magnitude of charge to give us enough vertical component to make the tape float. So that's why the line of charge model will have a higher magnitude. Thank you.